Hi everybody. So we're going to start Unit 2. And Unit 2 we're going to cover chapters 3, 4, and 5 in our textbook. Okay, so we're going to start with chapter 3 today. And we're going to start with some basics. Let's start with the basic atomic mass unit. Which is an AMU, or just the lowercase. Now, we actually define what an AMU is. Okay, we define it. Just like we defined what a meter is, exactly a meter is this long. We define what an atomic mass unit is, and we defined it this way. 1 AMU is equal to 1/12 the mass of a carbon 12 atom. So in a carbon 12 atom, there are 12 nucleons. 6 protons, 6 neutrons. That pen's dying. So we take the mass of one carbon atom, carbon 12 atom, and we know that that is 1.9927 times 10 to the negative 23rd grams. So we take that and we divide it by 12 because there are 12 nucleons, and remember all the mass is in the nucleus. So it turns out that 1 AMU is equal to 1.6605 times 10 to the minus 24th grams. So this is a conversion you should probably know. One AMU is 1.6605 times 10 to the negative 24th grams. Now these are big numbers, or not big numbers, they're really small numbers, but these exponents are a pain in the butt. And we tend not to like to do those. Okay, so we use a term called the mole. And all of you have used the mole before, but I do want to run through it with you a little bit. So a mole is what's called a collective noun. And you're familiar with collective nouns, so another example of another collective noun is 1 dozen. So if I have 1 dozen of something, that means I have 12 of them. Baker's dozen is 13. A gross is 500. So there's lots of different types of collective nouns. Well, 1 mole is just a collective noun. So 1 mole is equal to the number of carbon atoms in 12.0 grams of carbon 12. Okay. Now we know that 1 atom of carbon 12 has a mass of 1.9927 times 10 to the negative 23rd grams. So if I take 12.0 grams of carbon 12 and divide it by 1.9927 times 10 to the minus 23rd grams, that gives us a special number. And it's how we come up with Avogadro's number. We find that 1 mole is equal to 6.022 times 10 to the 23rd carbon atoms. Okay, so this number is Avogadro's number. and it's the number of particles in 1 mole of a substance. Okay, so let's look at how do I want to do this? Let's look at a couple things to start with, I guess. So this is exactly 1 mole of copper. So that means there's 6.022 times 10 to the 23rd atoms of copper in this sample. And compare it to this guy. Okay, so this is aluminum. This is 1 mole of aluminum. Again, it has 6.022 times 10 to the 23rd particles, or atoms, of aluminum. We could look at some other things. And I'll put it this way. So this is sodium chloride. This is exactly 1 mole of sodium chloride. There would be 6.022 times 10 to the 23rd particles of sodium chloride in there. And this is going to be hard to see also, but okay, so this is water. This is, again, 1 mole. It's kind of hard to see. 1 mole of water molecules. So we'd have the same number of molecules in this as we would in this. Okay, so these have the exact same number of particles. Now let's compare both of those to this guy. This is also 1 mole of this substance. This is copper sulfate pentahydrate. There are exactly 6.022 times 10 to the 23rd particles in here. Well, let's compare it to this guy. Oops. So my question is, why does it look like there's so much more of this than this? They both have the same exact number of particles. Well, the answer is that this particle, this copper sulfate pentahydrate particle, is much bigger than the sodium chloride particle. It takes up more space. So when we get 6.022 times 10 to the 23rd particles, it looks like we have a lot more than we do of the sodium chloride. All right, we're going to come back to those. And we need to define something called the formula mass. And the units for formula mass are AMUs. So when we're talking about formula mass, we're talking about the sum of atomic masses of all atoms in a compound. So when we're doing formula mass, you can round to the nearest hundredth. Okay, you can round to the hundredth. So let's say, okay, if I want to calculate the formula mass of MgBr2. So I want the formula mass. So what I'm going to do is you take the number of atoms. So I got Mg's and I have Brs. magnesium and bromine. I have 1 magnesium, I have 2 bromines, and we're going to multiply it by the mass listed on the periodic table. Right, so for magnesium, we can round to the hundredths place. It's 24.30. For bromine, it's 79.90. Then we're going to multiply across, and we get 24.30, and we get 159.80, and then we add those up, and we get 184.10 AMUs. That's a 4. So this right here is called the formula mass. It's called the formula mass. Now we need to compare that or contrast it with something called molar mass. You really calculate the molar mass the same exact way. There are other names for molar mass that you're going to see. It's also called the gram formula mass. We also call it GFM, gram formula mass. Okay, so if you see GFM, we're talking about gram formula mass. It's the same as the molar mass. Let's see, you might even see gram molecular mass. These all mean the same exact thing. Now, what is the molar mass? Well, the molar mass is the sum of atomic masses of all atoms in 1 mole of a pure substance. In my units, let's put units here. Units are grams per mole. So my molar mass, what this is really saying, is equal to the mass of 1 mole of a substance. So let's try it. Calculate the molar mass of glucose. Calculate the molar mass. This would be the mass of 1 mole of glucose. Well, we need the formula. Okay, so we have C6H12O6. Just list your elements. We got carbons, hydrogens, and oxygens. We have 6 carbons, 12 hydrogens, 6 oxygens. Now, rounding is going to depend on the problem. All right, so rounding depends on the problem that you're dealing with. If you're given if you're working with numbers to the 10th place, you want to round your molar masses to the 10th place. If it's to the 1's place, you can round them to the 1's place. So you really just got to kind of look at what you're doing in the problem. All right, so let's just do it to the whole number. So in this case, we look up the mass of carbon, and it's 12. Hydrogen is 1. Oxygen is 16. And then we multiply across, and we get 72 and 12 and 96. And we add those all up, 180 grams per mole. So this is the molar mass, which is the mass of 1 mole of sugar, or glucose, in this case. All right. Let's go back and look at this. So that's 1 mole. This is 1 mole of copper. Well, what's the mass of that copper? Well, the mass of that copper is the GFM of copper. And to get that GFM, or the molar mass of copper, here it is. It's 63.55 grams per mole. So if I was to measure the mass of this, it would be 63.55 grams, which would equal 1 mole of copper. All right. Well, let's go to our aluminum. This is 1 mole of aluminum. What's its mass? Well, its mass would be equal to 26.98 grams per mole. 26.98 grams per mole. So what we're really saying is 1 mole is equal to 6.022 times 10 to the 23rd atoms or particles. And that is equal to the molar mass. Okay, these 3 things are all going to be, okay, they're going to be equal. This is where we get these numbers from. Right? Now, what if I want to calculate the GFM or the molar mass of calcium iodide? Well, the very first thing I need is I need the chemical formula of calcium iodide. All right, well, we know how to do that. We crisscross. Ca is plus 2, I is minus 1. This comes over here, this comes over here, and we get Ca I2. So now I can calculate the GFM. We list our atoms. We got Ca's and I's. I have 1 calcium. I have 2 iodines. Okay. I looked this up. Calcium is 40. Iodine is 127. Multiply across. That's a 40. We add it all up, and it's 294 grams per mole. So if I wanted 1 mole of calcium iodide, I go to a balance and I would measure out 294 grams of the calcium iodide, and I would have 1 mole of the substance. Well, what's the mass of this sodium chloride? Okay, I want to know what the mass of that sodium chloride is. Well, I know that I have 1 mole of it, which is equal to its GFM, or molar mass. How do I get the molar mass? Well, I know it's NaCl. So I have NAs, I have Cls, I have 1 of these, I have 1 of these. I go to my periodic table, And Na rounded is 23. Cl rounded is 35. 23, 35. So the GFM is 58 grams per mole, and if I have 1 gram or 1 mole of it, that means the mass of this NaCl sample is 58 grams. Now, you can do conversions a couple different ways. Conversions between number of moles and mass. I use a formula. Number of moles equals the given mass. Let's write this. Number of moles equals the given mass over gram formula mass. I write it number of moles equals GM over GFM. You might see it this way. Mass equals N times molar mass. N is the symbol we use for moles. Okay, so this formula and this formula are the same thing. So let's try it. Let's calculate number of moles of water in 1.0 grams of H2O liquid. Well, I'd use the formula, number of moles equals our given mass over our gram formula mass. I need the gram formula mass. I have a given mass of 1.0 grams. So I have to do the GFM of H2O. So I got H's and I got O's. I have 2 of these and 1 of these. Hydrogen. Okay, so now this is to the 10th place, so this probably should be to the 10th place. So hydrogen would be 1.0. Oxygen is 16.0. So this would be 2.0, 16.0, so we get 18.0 grams per mole. So it turns out that if I had 1 gram of water, I would have 0.056 moles of water. All right? So that's how we calculate moles, right? You could use dimensional analysis if you wanted, and that would be okay. I think it goes through that. It might go through that in the textbook. I just think this is way easier. Let's try another problem. Actually, let's do it this way. Let's do a B part. Let's say this was A. Let's do a B part. How many moles of hydrogen and oxygen atoms are there in this sample? So I have 1.0, so now I know I have 0.56 moles of H2O. So in this sample, I have 2 moles of hydrogen for every 1 mole of oxygen. So if I have 0.65 moles, if this coefficient is 1, right? So if I have 0.056 moles, to find the number of moles of hydrogen, I'm going to have to multiply that by 2. And I'd have to multiply this by 1. So I would end up with 0.11 moles of hydrogen and 0.056 moles of oxygen. All right, let's try a different. You have, I don't know, how about 21.7 grams of NaCl. How many particles of NaCl do you have? Now, hold on. So you can't convert directly from grams into particles. Okay, we know we can't. When we're trying to figure out particles, you're going to have know how many moles this is first. So first thing we're going to do is we're going to convert to moles. Well, number of moles equals given mass over the gram formula mass. So my given mass is 21.7 grams. I need to know the GFM of NaCl. All right, so again, we're to the tenths place. So one of these and one of these. So Na is, well, it's still 23.0. And Cl is 35.5. We have 23.0 and 35.5. Oop, that's 34.5, so this would be 77.5 grams per mole. So I have 77.5 grams per mole. When I do that math, I got to do it here. 21.7 divided by 77.5 equals 0.28 moles. Now, how do I get that? How do I get that into particles? Well, it's a dimensional analysis, really. 0.28 moles. For every 1 mole, we have 6.022 times 10 to the 23rd particles. So we multiply across. And we get 1.7 times 10 to the 23rd particles. of NaCl. Okay, so that's just a typical problem that you might see. Let's try one more. Let's calculate the number of moles and molecules in 124.7 grams of ZN3 parentheses PO4 parentheses 2 dot 4 H2O. Okay, so there's a lot in this problem. First of all, I want to talk about this compound. This compound is called a hydrate. And I know it's a hydrate because it has this dot H2O after it. Now what that means is that this compound traps water inside the crystal lattice. In other words, if I have a solution of this zinc phosphate and I let it evaporate, as this crystallizes, it traps water molecules inside it. You can't see the water molecules, but it does. This dot doesn't mean times, it just means and, or together with. So this is ZN3PO42 and 4H2O. This is one big compound. Okay, so the water becomes part of that compound.